Welcome everyone. This tutorial we are going to create a camshaft system, this system in here, where we're going to put an engine in here and we're going to see as the cam is moving, it is lifting up and down the pin. In order to do this system, we have to do first of all three different parts. We're going to design the base. Following that, we're going to design the pin. And finally, we are going to design the cam. So this is the base part that you want to design. This part has this shape in here. It is to make sure that it is steady and it holds on. And it has in here, so I'm trying to think at the same time as I'm looking at the part. So first of all, I always look at the isometric view. This helps me. And then after that, I start looking into which dimensions. This part looks like I'm going to create this profile and extrude that profile. You know what? Actually, I'm going to do this profile as well as this circle as well as this circle in here. So let's see a little bit zoom. Yeah, it is a hollow circle, and most probably this internal radius of 15 should match with the cam. Let's see in here. So yes, you have a diameter of 30, so which is a radius of 15, which is good. So we're going to create this whole profile. Let's see the dimensions. So we have the dimension all the way till the top. So I'm going to include this portion in the profile. Do we have any knowledge about this dimension here? Let's see. So we're looking from this side. This is the radius 10. This is in this corner. This is 350. This is for the base, and it's 350 from one side and 540 from the other side, and it's centered. So that's easy peasy. And this is 20. So if we use this plane as XY plane, let's go ahead and do that. So start mechanical design, part design, and we're going to put in here PRT RH base V01, and we're going to save that somewhere on the desktop. New folder, Camshaft system, and we're going to create, oops, that's not what I want, new folder, parts. We're going to have another folder called assembly for mechanism. So we're going to save this in part. Here we're saving this in part. Let's go ahead and use a centered rectangle. So this is one of my favorite functions when you actually create something that automatically has different values that you can use. And I'm gonna move this part to the side so that I can have access to the dimension at the same time as I'm working. You have access to the Word document. So this is 540, and let's zoom all in. And this one is we see 350, and we close that. So the way that I'm going to extrude towards the bottom. So I'm going to use the XY plane as my reference so that I can build on it the other profile. And the dimension here is 20 millimeters. That is good. And it does have a filleted radius of 10. So we're going to press fillet and click here to select several objects. So we're going to do this one. We're going to do this one. I'm going to show you also a function and this one. So click close. So the radius is of 10. We're going to put in here 10 millimeters. Preview. That looks about right. All right. All right, perfect. So we have the base. I'm going to position it a little bit like the isometric view. Now we're going to select the Z-axis plane, so this plane, and we're going to create a sketch on this one. So if you take a look at the drawing in here, Let's zoom out a little bit so that we can see all of it. If you take a look at the drawing, so we're going from this dimension, so from here all the way to the top, with the exception of this protrusion. The reason we can include this protrusion, no problem. I mean, we can do that. We can, let's see the dimension, the thickness. Where do we see it? This is a 20. This is a 5. No, this is a 5 here between these dimensions. So in here, it's a series of centered circles of radius 15, radius 20, radius 100, and radius 175 for this. This dimension is 40, so we can get away with making this a complete circle if we wanted, and then canceling it, or we can just build that profile. So looking into what we have, this in here, don't confuse it. This is a little fillet between these two. So we're going to discard this line. We're going to create a profile that is a line, circular line, and we continue with a line. So we're going to include that 20 with all of this. So this is 600 and this is 20. So it's actually 620 all the way to the top. And then there's a 40 dimension in here, this radius in here, everything is centered, and the below dimension. So I think we have everything we need. Let's see if there is anything missing, if any dimension is missing. So if we do this, so the center here, I cannot, let's think of this, how can we, these are dimensions that are offset along Z. So these don't really help. This one is from the top, doesn't really help. This one is 600 all the way till the top. This is 100 from the center to here. 40, 20, it doesn't help. Center, so this is an AA cross section, whereas this is a section view in the middle, so that we can see it. Where does it show us? I think we have a missing dimension. I think I'm looking at this and I think there is a missing dimension. But before I judge that, I am going to actually create the profile as usual, put the dimensions we have, and see if it ends up being ISO constraint or not. This is our best bet. So let's go ahead and start doing that. So it would be useful to bring this edge. So I wish I did not do the fillet yet, but it doesn't hurt to actually bring this and this as a projection, and I'm gonna make them as construction elements just so that I have them in my sketch. And then we're gonna click on profile. I am going, so of course no longer construction element, so we're going to build it and see if it ends up being, so from here to here. Then we're gonna go on a vertical. We don't really know the dimension of this yet. Then we are going to go in a tangent way, all the way. Oh, you know what? It is limited. All right, let's see. We'll discover that shortly. And then we go up. Let's move this to the bottom. We go up a little bit. Then we come back in a centric fashion. We have to create this. And then we have a circular. So in here, it's not really okay, so this one is gonna, let me escape this one and continue the profile from the other side. I should have clicked the center on the other side. It doesn't matter. And we're gonna go up. We're gonna do a tangent circle like this. Okay, all right, perfect. So now let's go ahead and make sure that these are concentric. Okay, let's put the other dimensions first. So let's put a dimension on this one, and let's put a dimension on this one as well, and on this one. And then let's put a dimension from this to this. here, and make sure that this is always equal half of this, so that they are always centered. Okay, this is good. So we have these are centered. The dimension of this height in here is, this is one of the problems, that we don't have this dimension, unless I am not seeing it anywhere. Let's see one more time. We have a 600 to all the way up. We have 620. So basically we do have this dimension from here to here, and that dimension is 620. All right, now these radiuses, this radius should be 175, and this radius should be equal to this radius. Okay, so which is good, which it makes them centered. All right, this confirms that we have a missing dimension. This confirms I did put all the dimensions. So the 620 comes from 610. So in here, these dimensions, we all have them inside it, inserted. From looking from here, the 350 is there, the 10 is there. This is the radius of the top of the pin, no problem. From looking at this one, um, I think this is the center of all of this. Well, we cannot really confirm it, so let's make sure we generate a new distance. I'm going to open the original file. All right, let's see. Let's verify if we were missing a dimension, or we missed something out. Let's go. Just give me a second to open the file. This is tutorial 7. Aha! I don't have the files for this one. That's problematic. All right, so all right, we are going to do something that I don't usually advise people to do, but let's see if we can do it. All right, exit workbench. Let's see, and snippet. So I just want to verify where is this located, and I want to see if there is like a dimension that we missed somewhere, and take a look at that dimension. So what I'm trying to do is I'm going to create a line, and I'm going to see within PowerPoint if there is something like equal, if let's say the distance from here to here is the same from here to here, or so on. So this is what I want to try to do. And in order to do that, there are two ways to do it. This is the easy way in case you have access to, I mean, you can print it out, and so you can actually literally print it out, because they are to scale. I mean, you can print them out and multiply them by 8s. So you can actually do that, or what you can do is try it out, what I'm doing in here, which is basically just trying to see. I feel like there is something here where it's like centered somewhere, so this is what I want to verify. Where did Rami go? Should go here. So what we know is we have from this, let's put it in purple, from this purple to that purple, we know that we have 600. So we know we have this dimension. So next thing, what I'm going to do is I'm going to connect these both here. All right, cool. So let's see if this one, I'm gonna paste the same value. Is this centered? Yes, that's what I suspected. I suspected that this is centered along this whole distance. So basically that point is 300 from the bottom because you have 600. So this is I mean I this is one trial how to do it. The other way that you could have done it is literally printed out and measured, and this is scale 1/8. So which means if you print it without zoom in and zoom out, you will be able to get this one. So basically what we recovered is that this point in here is 300 from the bottom. So we are going to come back here, close this one, we don't need it. I'm gonna move this back to the other side and zoom back here and go back into my famous sketch. So if I go ahead and do it right now, it's gonna mess up because I did constrain this, which was not existent in my file. What I'm going to do now is I'm gonna say, hey, from here to this point, this is 300. And well, basically this point and this point are concentric. And that should solve everything. So coincidence. What did I do? More than, so what happened? This one can move up and down, which is not good, which means it's not ISO constrained. So this one has to be with this one. But if I put them like this, let's see if I try to do another dimension from this one to this one, if it will like it. Hey, that's okay. I mean, that's another way around it. Here we go. Okay, cool. So we have our dimensions. I'm going to, if I had the printer at hand, I would have done this on the printer and made measurements, but this is just another way to actually also send to back. This one here, let's make a set transparent on the white, and let's delete everything that is not the dimension that we want. Okay, good. So, and then I am going to make this a little bit smaller and try to see if it's, where is it here? Ta-da! It's perfect. Yeah. So did we miss any dimensions? Did we miss any dimensions? So let's see. The 175, 175. Oh, the top. Haha. This is why it was not fitting. So the top should be 40. So once again, you got used that I am doing these live in a way that to make sure that you're profiting with how I'm thinking as well about them. So I'm going to go ahead and close this sketch. Oh, actually, I wanted to do something else at school. So we're going to create all the other circles that we have. So let's go ahead, and there is a radius of 100, 20, and 15. And you're gonna see a little bit something that, so let's double click on circle and do one circle, two circles, and three circles. Oops, not four circles. And let's put the dimensions on them. So watch out, these are in diameter. So what's listed, 100 radius. So you can put 100, just make sure that you put here radius. So that's the 100 radius. What did I do? Oh, I changed it when I clicked radius. So 100 radius. This one, we have a 20 radius or 40 diameter. And this one we have a 15 diameter, no, 15 radius, so 30 diameter. And to avoid confusion, we can click radiuses here and radiuses here. So I have all of them, which is very, very useful. Let's verify them again one more time. 175, 100, 20, 15, 40, and the other dimension, and 620. Now, keep in mind it's 620 because I have included this in it, this portion, which we're gonna go from this distance. So basically, when we're gonna create this, I'm gonna create a sketch on this that is these dimensions, and these dimensions are 20 by 40. So 20 by 40 by 100 minus half of this, and half of this is, we have to do some calculations when we come back here. So 20, 20, 40. So basically that's a 40. So we have a 40 in here, and um, that dimension is useless because that 5 is nothing but the difference between 15 and 20. But I mean, it's useful to confirm. So basically, actually, this is very, very useful to take a look at right now, because this is a through hole. This one is 40, the little 5. Then this one in the middle, all of this is 20. Then this one is 40. So we are actually going to use a very cool feature, which is called multipath. So if we have done everything right, we should be able to create multiple profiles. So this profile, this is the external profile. This has the full 40. But keep in mind, we want to create it symmetrical. So we want to create both dimensions. So we don't want it to be only from one side. So we're going to create, because it is centered. So we're going to put 20 in here, and then 20 in here, and click preview. And this is what we have. Now, this dimension, this circle, this one is which one of them? This one is the little one. This little one was this one, and then we have this one. So this one is going to be only one-sided. So it's going only to be to the back, and it's going to be 20 millimeters. We're going to verify all of that. Preview. All right, cool. Now then, this one, which is, so let's see. This one, where are you? Yeah, this one. This is in between both. This is going to be a complete 40. So 20 from this side and 20 from this side. Preview. And the last one, actually, there is no extrusion. We don't want to extrude it. So we click OK, and voila. So, and if we look at it, let's go ahead and put the view with edges so that you can at least see all of these things. So let's confirm what we have so far and make sure that we did not miss anything. So we have all the circles. We have this, like I'm looking at this dimension in here. So we have this 5 is for this one, and here is between both. So this comes from there. So what we have is 20, so which means there is a pocket of 20, depth of 20, and there is 40 all over, and it is centered. That's perfect. So this brings us to the last portion that we have to do, which is this step in here. This step in here is going to be based on what we created. So we already gave it 20, so we only have to add 80. So we have to add 80 for 20, 40, 80. Let's go ahead and do that. So we're going to click here, and we're going to create a sketch in here. And first of all, we're going to bring this one in here, project it to us, we need it. And then we're going to continue the profile that we have, basically a 20, oops, you should double click at the end. So double click here to put some dimensions. This is a dimension, this is projected. So actually it's already all good. We don't need to we just need to adjust this to 20. And we are going to extrude this from here. And we had a remaining 80. Preview. That is perfect. So we have in here a fillet of, we can start filleting if we want, a fillet of 10. Preview. Okay. Did I forget any fillets anywhere else? Yeah, here at the bottom. So let's take a look at the final things we have to do. There is a fillet in here of 10. We did already these edges. Everything else is done. And we still have to do the hole in here. So the hole is 25 from here. So it's 80 minus 25, or 25 from this one. And that hole is, where's the dimension? 7.5, and it's centered. Let's go ahead and do that. So fillet of 10 and the pin. So let's select this one in here. and this one in here and fillet them with 10 millimeters. And then we are going to pick, I'm going to select from here. It's going to be easier for me to do the hole from this side. Well, it will be easier if I can see it. But basically, all right, so we're going to do the fillet from here. We're going to do the calculation from the other side. So let's take this, project it to our side, and make this as a construction element. And looking into the dimension that we have, we have 100 to the center, so we have an 80 to here, and from 25 the center, 80 minus 25, that's 55. So we have 55, and it is a radius of 7.5, so 55. So we're going to put a circle. It's going to be centered somewhere here. It's not going to be a construction element, and it's going to have a radius of 7.5, and it's going to have a dimension from here to here of 55. And we are going to pocket this sketch, so we'll make it up to last, nope, up to next, and we have the base. Now we move on to the second part, so let's do that. We are going to design the second part, the pin, and I've placed the drawing next to Katia just to illustrate a little bit how you can actually work. If you have like two screens, it's much be easier, but usually you can also work also like this. So let's go ahead and do this. So we're gonna select, so it's very important to understand that this is a revolution part, which means the best way to do it is create a profile in Axis and revolve it. Let's go ahead and demonstrate that. The first thing that you want to do is create an axis that is approximately, so we have 415. We're gonna start this point here at the 0. So I'm gonna create like an axis that goes a little bit towards like 400 and let's say 30 or so on, like just a little bit more. And then I'm gonna click zoom all in and make sure that we have this dimension. Now let's go ahead and click profile. You know by now this is my favorite button to actually work with. So now we're going to create something that is approximately 45 degrees. You can see the angles from here. So 45 degrees was approximately a height of 7.5. So that's good enough. Then we're gonna go up all the way, approximately like 400. Of course, we're gonna put dimensions later. Then we're gonna start creating this circle here. So we're going to click on this point and let's go ahead and put a center and a circle. Don't mind if it doesn't look right. It's okay. A line, going up a line, another line, and finally a circle that will be like, let's just do it like this, and that will end here. All right. So this is approximately the profile. Let's go ahead and start putting some dimensions so that it looks a little bit more close to reality. What is it that we have? We have this one in here is going to be from this point to this point. We have 7.5. You can see the value here from the section B. So this is here. This is section B, 7.5 and 45. So let's go ahead and put this 7.5, and let's make sure we put an angle of 45. So it helps when your dimensions are very, very close. Now we're going to zoom in this area and try to see what we can make out of it. Basically, we have, this is a 25 radius. I'm not a big fan of starting putting the radius. I'm more of a fan of trying to put some of the dimensions first. So for example, this one, 2.5. I would put this one, 2.5. All right. Then we have, let's see what else. So this is section A, detail A. So we have 12 from here to here. 7.5. This can be useful from the top to this point. So from the top to this point here, that's gonna be a 7.5. This is gonna mess up how it looks like, but that's okay. This is totally fine. And this one you can actually, like, if you want, literally. Oh, I had the selection picked, so you can actually move. This point is right. This one is okay. So you can literally move what you want. I mean, the circles and the whatnot. So just to make it look almost the same before you put some constraints and not to mess it up. So this is good. This is good. What else do we have a dimension we can profit from before we put, oh, this is the top view. So this gives us that this internal diameter from here to here. Oh, so this gives us the dimension. Okay, so first of all, let's go ahead and make sure that these are centered. So basically this is a 0. Oops, what is this? Oh, I don't know what I pressed. 0. Okay. When I watch the video, I'll see again what I pressed. And this is a 0. So these are along these lines. Perfect. Next thing is from here, from this point to this point, to this line. This is the outer diameter here, 56.6. Of course, we'll have a radius. So 56.6 divided by 2. And then what else do we have? What else do we have? Oh, the dimensions, we didn't put them. This one should be a radius of 27.5. Okay, I'm gonna put Control Z because very clearly this one should be, what is missing? Ah, let's put this dimension, the 415. From here, okay, I should have done this a little bit earlier, but this is 415. All right, we're gonna fix how it looks like in here. So that's not a problem because you can still drag. I mean, you can like make it look approximately. So let's try this one out now. What was this dimension? 27.5. That looks perfect. And this dimension, the radius, should be a 25. So that is okay. What did we miss? What dimension did we miss? Okay, this one. So you see this 32.6. This is the value from here till the center in here. So basically from this point to the axis. Ta-da! And this one is 32.6 divided by 2. Well, we better type it the right way. 32.6 divided by 2. And we have our dimensions. So we have the 25, we have this one, the centricity. So we can verify that in a few seconds, but this is basically how everything should look like. Now, the good thing about creating the axis, it will revolve it automatically. So if I close this and I press revolve on this axis, if we've done everything right, voila, we have our pin. Did we mess up here? Is it a pin? Yep, it is a pin. So let's go ahead and save that part. This is our second part. File, save. Let's go ahead and save it with the parts in here. And let's do some validation and verification. I'm gonna just bring this measurement device here and let's just make some validation. So this one in here, that's a 32.6. This one, that's a 56.6. We can see them in here. Well, it's very good. So we can click from here, from this plane all the way to that plane. That should be 415. We can come and select also from that plane again to this plane. That should be the thickness of 2.5. We can select literally different elements. So it looks good. All right, we're going to close this part and move on to part 3. Time for part 3. We're going to design the cam now. Let's go ahead and PRT or H cam V01. We're going to click a sketch, select the XY plane. So this is how it looks like. There is a missing dimension that the centers of this circle and these two concentric circles are 70 millimeters apart. So this is an additional dimension that you would need. We're going to create a circle, create another circle, a third circle, create bitangent lines, and put all the dimensions. Let's go ahead and do it. So I'm going to double click so that I can create several circles at the same time, and then a third one in here. Then I am going to create, so this is the icon underline, you have a bitangent line. So I'm going to select these circles and create those bitangent lines. Next thing is I'm going to put the dimensions. So the dimension of this one, dimension of this one, and finally the 70 from here to here. We're going to update the values. This should be 30 radius. This should be 60. And do we have all the values that we want? 60. Oh, this one here should be 30 diameter, so 15 radius. So this is how it looks like, the part. 30, 60. Yep. So now we're gonna do a quick trim of these sections. So quick trim, wherever you click, it would remove it and leave the other side. And now we're gonna go out from this. We're gonna use the multipad to create on the first domain a value of 50, and on the second domain a value of 50 on top of the 55, so that is 105. Preview, and we click isometric view, and we have our part. So now we can save this one in the same folder, and we move on to the final part, which is the assembly. So at this stage, what we want to do is we want to create the mechanism. So first of all, we're going to click assembly design, where we're going to create the assembly. Let's make sure that we change the name to PRD RH Camshaft Assembly V01 and save it. We don't want to be losing it, so we can save it under PRD for product and assembly. Insert existing components. If you don't have something on the screen, make sure you click on the link on the top, and we're going to select the full set of parts. Now the first thing that we do, I'm going to right click, snap automatically, is we are going to try to assemble things as close as possible to how they should be. So the pin, let's go ahead and move the pin a little bit upwards. So the pin should fit in here unless we did something calculation by mistake, and the camshaft itself should be fitting in here. All right, let's go ahead and move this one around a little bit. So we're gonna move it like this and move this one down. All right, so now that we have these things, we're gonna stop the snap fit and we're going to start some of the constraints. Let's start with the concentricity. So we're gonna do coincidence between the axis and the axis. So this would be really helpful. You can press Ctrl U. Okay, so I'm gonna put Ctrl Z because what I want is I want to fix the base. So you always want to do that so that everything moves with respect to that component. So now we have fixed the base. Do I still have the constraint? No, I lost it. No problem. Coincidence. You can zoom in here and here. And now Control U, the pin will go there. So that will be sufficient for this one because they're going to be sliding on top of each other. And then in here, we are going to have absolutely this constraint, but also we're going to have a contact constraint between the top surface in here and this value in here. So let's go ahead and press Ctrl U and see what happens. Perfect. So we are in the right dimension. So I wanted to say something about the different dimensions and the values that we have. So keep in mind that this was a completely set exercise, so things are connected with each other. So the dimensions from this one, which is the center, to this one, you can see in here, this dimension is actually going to go all the way from the center to this 100 radius. So in some other sense, we could have guessed that this is the dimension that we have. So I'm gonna just go inside of the cam for a second just to explain a little bit what I was saying. So earlier we said, hey, we don't know, like there is a missing dimension 70. But if I delete this missing dimension, which is not really like missing, and I take my understanding that this is, so if I go back to the base and I double click, I think this one. So this one, this is gonna rotate within that base. So from this point to this point, we have this radius, which is equal to 100, which I cannot find anymore. Where is it? Here. This radius, which is equal to 100. So if I exit the sketch and I go back to my sketch in the cam in here, we can easily put this constraint going from here to here and saying this is 100 and then close this one up. And this would create my whole mechanism. So let's see something. Do we have it from the other side connected like this? So this is how we can have the engine. So I'm looking at the dimension in here. This looks like as if this is holding on completely there, but it doesn't really matter. What we're trying to do is we're trying to create the mechanism. So that's what really matters. So we're going to suppose that this is how it rotates, and we can actually think that we are going to mount a shaft on the other side, or if you want, we can actually do something which is update the cam to include this hollow area. So let's go ahead and see what we're talking about in here. So if I bring this here and I move this, so you should not never do this when you're in a part. You should go back to the assembly. Where is okay, and then do this here in the assembly, because in the part you would change the part reference. So what we can do is if we wanted the part in here, this one, to mount on this one, and not to have this collision in here, what we can do is create this 20 millimeters hollow area. So let's take a look in here. So if we go back to this location here, so this is a, no, sorry. If we go back to this location, this hollow area of R15, and we can actually create that. So like from R15 to R20. So let's go ahead and do that. Just for the sake though that the exercise is complete. And that's okay, we're updating a little bit the dimensions that we have. So we're going to go into this multi-pad in here, and I'm gonna click on this one to fit all in. And what we're going to do is this 15, we are going to add another circle. So let's get rid of the compass so it doesn't mess us up. We're going to add another circle that is centered here. And we are going to say that this circle is my 20. Now when we go out, this is what we're going to happen. Yes, of course, it's going to impact modifications because we created a surface. No problem. When we go out, we are going to do the following. So this pad, we are going to leave it as is. This dimension in here, this one, we're going to reuse the value that we had. So a value of, what was the value? 50. So this is a 50. Okay, now this one, which is the hollow area, this is the one that we're gonna do it equal to 30. Why 30? That's 50 minus 20, which is the depth of what we have. Let's see it. So now what we have is, okay, let's move this a little bit more. Nope, never do this modification on the cat part unless you intend to do it, never to do it. And now we have this hollow area that matches this one. So what we can do now is, now that we're back to this one, we can go and look at the constraint. We're gonna delete this constraint because it doesn't exist anymore. This one is actually still the same. So let's go ahead and try and press Ctrl U to see if it aligns. Perfect. And then we're gonna put a contact constraint between that face inside. So I'm gonna teach you something else. So let's say you don't know how to click it and you cannot access it and it's between so many things. You can click on the bottom arrow, so like on your mouse, and like it can help you see through the different element in your parts. So let's click on this one here and click on this top face here, and now press Ctrl U. So now it fits perfectly and we have the little engine that we can fit on the other side, and we can actually try to simulate the motion before we actually, I want to do something. I want to make sure that this enters in contact with the face below before we put the kinematics. So I just want to, okay, perfect. I'm gonna hide these properties here. Hide these references, and file, save all, yes, isometric view, fit all in. And now what we can do is, with the exception of this pin, if we click, because we have a fix on here, if we click manipulate with respect to constraint and we put an axis, which is this axis, this is where we're going to put the engine, it should rotate perfectly. So now what's still missing is the final one, which is the contact between the pin and the cam, which is something that we are going to do within Kinematics. All right. All right, this is the final part that we have, and we're going to go ahead and open up our CAD product. So the first thing that we need to do is we need to do some modifications. We are going to see that what we're going to use in here, we're going to use a point surface mechanism. So basically we're going to create a point in here and a surface in here, and we're going to make them follow each other. So first of all, we're going to double click on cam and create that surface, and you're going to see how you're going to start using different tutorials. So you can go to shape and generative shape design, which I'm already in it, so I'm going to click X. Then we're going to extrapolate the surfaces and create an offset with 0. So we're going to do that for every surface, and this is from the other side, and now this is our final surface. So now we have these 4 surfaces that constitutes our cam. We're going to join them so that they behave as one. So this is the first thing that as modification. So let's save all. The second modification is we are going to add a point to the pin in here. So we're going to go to mechanical design, part design, and we're going to create a point. So we did all of our design with respect to this point, so we can actually go ahead and click this one and take the coordinates. If not, we could have tried to do a different setup. Now we're going to go back to assembly design. If I'm moving too fast, just pause and go back and take a look into what you want to do. What I'm going to do is I'm going to make sure that this point actually is in contact with the surface. So I'm going to put an offset constraint between the point and the axis in here. And I'm going to say this is 30. If you remember, 30 is the radius. So now I'm going to hide this. Actually, I'm gonna delete this altogether. Like, it's sufficient that we have it now. So file, save all, yes. And we had our constraints that we created before. We're gonna go back to our product and go into kinematics again. And now we're gonna start creating our mechanism. The first thing you want to do is always to translate the assembly constraints, these ones, into mechanism. So mechanism one, auto create. So let's see what it created for us. We can now close these ones. So in here, this is degree of freedom 3, means we cannot really simulate. So it took what is fixed. Let's go ahead and do something interesting before we continue moving forward. Let's go ahead and change the colors of our parts. So let's go ahead and change the base to something that is brownish. Let's go ahead and change the cam itself into something that is like strong yellow. Okay, so in here we're gonna have to do it on the part body, and like we're gonna have to manipulate the surfaces a bit. Let's just use this one, strong, and then the surfaces, the join on the surfaces, we can use, let's use a strong green. All right, not my best choice of colors, but it is just to make things easier to observe. And I'm hiding a little bit some of the planes. All right, this is good. I like this. The pin and properties, we're gonna just go ahead and do this some strong blue. And okay, here we go. So at least so that we can have, and we can hide the constraints, we don't need to see them. So this is good. So we have some of the coloring so that it can help us out. I'm gonna save all. And let's go back to mechanism. So double click on the product at the top. And this is where we are. So we have a revolution joint in here. This is where we're gonna put our engine. So this is gonna be angle driven. This is good. This is a cylindrical joint. So this is gonna be problematic if we don't go ahead and put like a angle driven as well on this, so that actually so a cylindrical joint means it can rotate like this as well. We're gonna, if we wanted it just to go up and down without this rotation, we could have tried to create a prismatic joint. So okay. And we are going to add the most important one, which is, you can see it in this bar, which is the point surface joint. So we're gonna go ahead and select the surface. I prefer to select the surface from the design tree, just to make sure that I selected everything that I want. And voila, this means that the mechanism can be simulated, and this is good news. This is what we're hoping to get. So let's go ahead and simulate the mechanism. I'm gonna save all, just make sure that we have it. So keep in mind, you have to revise those steps to create the surface, the point, and so on. So let's go ahead and click simulation with commands. So it opens up for us the different commands that we have. And actually, so there is different like methods, like you can click simulation in here. It can open it up with you, like they can be detached. So now keep in mind, we have two angles in here, although in reality what we want is just one angle. So this is the one that we want, which is like the piston, like we want the cam to rotate. This one, and observe what's happening. This one it is rotating on itself. And this is not something that we want. I mean, it doesn't, if we wanted it, we can create it, but I'm not gonna play with this command. So let's go ahead and for this one, and create at 0, and click insert, do in 180, click insert, do a 360, hopefully that returns it to its position. I mean, we will see in a second. And let's go back in here, make this slow moving, and see how it goes. Well, apparently we entered the same, okay, so I did enter the same angle twice. No problem, we can delete that. Okay, good. So we can go back in steps. So this was um, the different steps that we have. So this is first step. I can delete this one and press play again so that it actually like the stagnating one that doesn't go around. So here we go and voila. So now we're gonna make it continuous and go back and I'm gonna make it a little bit faster and let's observe it. And now it pushes up and down. Now it pushes up and down. All right, so this is our simulation. And what we can do now is actually try to take a look into the different joins that are happening. So try to take a look. So what we are interested in, as the angle is moving, we're interested to see how this is going up and down. So basically, as this angle is revolution 1. So if we go in here, this is revolute 1, this angle. So we're going to activate this one. So let's bring it back here to 0, activate this one, and we're going to activate the length. So this is what we have. And now we're going to play it. So now as it's going, we are observing it. And you can see in here what's happening. So let's go ahead and return to the start, put a small pause, put a small speed, and look at this. So, so the length is not changing, it's not changing, which is very logical. And now it's hitting. It goes up to 0 and then go back to this value of whatever is the value of minus 28.3 and so on. All right, and then it's gonna go up and gonna go down. So now what we can do is actually, let's close this and click OK on this. So this is good. This is at this point, but what we can do is also look into analysis, like animate things, look at simulation, look at sensors, activate them from here, and so on. So there's so many things you can like. We can put speed and acceleration. We can select, hey, we want this product to understand, and we want this point. We can select the point that we want, and you know, you just, as if you just activated a sensor in here, and you can observe what's happening with the sensor. So you can activate the sensor and look into the simulation in here. Look into the simulation in here again, if needed, and so on. So thank you so much for listening to this tutorial. It's a little bit long. Take your time into understanding and doing it. Thank you so much. All right, I figured that I'm going to add something very small, but something that's very, very powerful. I figured that it would be a shame not to show it to you, which is I am going to activate the sensors once again. So the angle of the revolution in here and the linear one, and we're going to plot a, so these are the values. I mean, this is the history that we're gonna do. So I'm gonna be moving this one all the way from 0 to 360, as you see it in here. So basically it got a full loop of values, and what we're going to do is we're going to click graphics to see. So what we should see is an angle going from 0 to 360, and parallel to this, a distance that is constant, and then it moves up and down. So this is so powerful so that we don't see it. And let's see in here. Okay, so I I did by mistake the angle and the angle. This is not what we want. I'm gonna clear it all. So basically, let's go back here. Actually, I observed the two angles and the other angles. So what we saw, okay, what we saw is one angle going from 0 to 360 and the other is steady. We're gonna unlock this one and we're gonna activate the lengths. And actually, I am going to move this all the way back here so that actually like we can get two rounds from 0 to 300 to 720. I am going to clear the history so that we can, and now I'm gonna move. Now we're observing the right ones. And here we go, 1 and 2 cycles. And now we're gonna go to plot this and look how beautiful it is. This is the angle, this is the 720. So this is going from minus 360 to 360. Of course, we can simulate it with lows and not command. I can show you that as well. And you can see in here the distance. This is going, it is, so if I click on this one, it is remaining at like the value, going up and then coming back down and so on. So this is a little bit the power of the software, and this is something that you might want to play with. Another thing that you can do is simulation with lows, and I will leave that for another video. Thank you so much for listening to me.